Hey everyone. This section is going to be a little short, so that's good. But we're moving on. 4.4, 4.5, 4.6. So it's this section. On Thursday, we're going to do 4.5. On Tuesday, 4.6. And then the next Thursday after that is going to be the exam. All right, but anyway, this section is talking about the big three logarithmic properties. So we talked about logarithms last time. For the first one, we have log. Let me see if I can write this out. Base A. So it's called the product rule because on the inside you have a product. M times N. There's just two things being multiplied. So there's that. What happens is if you ever have multiplication as the main idea, let me kind of clear that up. Main idea. Whoa. Need to go find my gloves so I can put them on. So if multiplication is the main idea inside your expression, I can rewrite this as log base A of n plus log base A of meh. And all you do is the m goes here and the n goes there. So if multiplication is the main idea, you can split it up with addition. The first part of the product goes in one log. The second part of the product goes in the other log. Now the same thing with the quotient rule. If you have division like this, all right, again, if division is the main idea, then you can split this up, but this time with subtraction. So log base A of minus log base A of n. And then finally, the power rule. The power rule says that if I have log base A, if I have a power, I'm just going to say m to the r. So if the power is the main idea, meaning that in the entire log, the main thing happening is the exponent, you can tell what's the main idea by using your order of operations. But what happens is that we get our log base A of n, m goes on the inside, and the r goes in front. So really what happens here is this r kind of flies to the front. Okay, but it only does that if it's the main idea inside the log. Right? So first, let's talk about stuff that are not logarithm rules. These make people sad, and I will end you. That's the joke there, but they're cats. Back in 2003, 2004, that picture was like the funniest picture I'd ever seen. Anyway, so what they're not, the biggest mistake people make is they'll say log A of m plus log A of n. You can't do that. If addition is the main idea, you can't split it up. Okay? Same thing. If subtraction is the main idea, oh, that's what was written already. You can't say log base A of m minus log base A of n. That is also forbidden. And again, this is if addition or subtraction are the main idea. Basically, the main thing happening here is either addition or subtraction. Then you can't do it. You have to leave it alone. Okay? So if addition and subtraction are the main idea, walk away. You can't do anything. Well, technically there is a trick you can do, but you have to turn it into multiplication. But for now, if addition and subtraction are in there, are the main idea, the main thing happening, just walk away. Right? The other thing that angers Gilbert is that when people see this and they say, oh, this is just log base a of m times log base a of n, that is also forbidden. You have to use the rule. And the product rule is this one that we just talked about. Okay? Same thing with the division one. You can't do log base a of m over log base a of n. That is illegal. Okay, and then for that one, you would use the quotient rule. Okay, so these are the mistakes that I usually see people do. They try to get a little carefree with the way they work things out. The last one is you can't distribute the r inside the m. So it is very bad to write it like that. Okay? Don't do it. Okay? You can't distribute to the inside of a log. What happens instead is if you want to distribute, if you want to bring it in, you have to use the power rule. Okay? So the power rule is this one. Notice what it's saying is that if you have a number in front of a log, what happens is the r becomes the exponent. So if I had 2 log base 3 of x, it's not log base 3 of 2x. What happens is the 2 comes in as an exponent. This is log base 3 of x squared. And that's the key idea here. You can bring the number inside the log, but it doesn't distribute. It becomes the exponent. So I know it's hard to, these are just right off the bat things that I usually see students make. Other things that I see, I'll kind of try to write them to the side, is it gets a little confusing. Let's say log base 3 of x squared and log base 3 of x. Let me not put the x in parentheses. Squared. So these two are different. In this one, this comes to the front, and that's just 2 log base 3x. Here in this one, it's different. It's log base 3x times log base 3x. So the position of the exponent matters a lot. That tends to get people when they're new to logs. So be careful to the position of the exponent. If it's on the inside, then yes, you can use the rule. If the exponent's not inside the log, if it's on the outside of the log, then no, it's just a regular square. It's the same thing twice. And those two things are not equal. Anyway, let's go ahead and do our first examples, the main things we're going to do in this section. So the first thing we're going to do is what's called expanding logs. And so what you're going to do is you're going to use the, oh, no viruses. You're going to use the power, product, and quotient rule to make each log as long as possible. So you're going to turn each expression into a bunch of smaller logs. Okay, so you have one log and you're trying to turn it into a bunch of logs. So here's our first example. The main thing here is we need to look for the main idea. So let me get this, what I just wrote. Let me try to maybe write it over here. Let me shrink it. So look for the main idea. Inside the log. So what I mean by that is there's one operation that is above all the others. If you were going to do order of operations, what's the first thing you would do? Okay? And based on how it's written, that can be add, subtract, multiply, or divide, or exponents. So look for them. The main idea, again, can be addition, subtraction, multiplication. It's kind of weird that it's just, okay, well, in this context, it's just multiplication. Multiplication, division, or you can have an exponent. I don't know how to do an exponent. Okay? The main idea can be any one of these 5 things. Okay? If it's these 2, walk away. Basically, if the order of operations, the first thing you would do, the main thing happening is you're adding or subtracting 2 things, walk away. If it's the other side, though, if it's any of these 3, then use the rules. All right. So let's look at this first one. I look on the inside, and I see that this is 125x. So what's the main idea? The main idea is that it's multiplication. So that means that we're going to use the power rule. This is log base 5 of 125 times x. So as far as my terms go, here's my first term, and here's the other term. Now I just split it up. This is log base 5 of n, and it's multiplication, so that means that I split it up with addition. Log base 5 of n. The 125 goes here, and then the x goes there. There you go. You split it up. These 2 expressions are exactly the same. Oh, undo. All right. Now, sometimes you can go a little further. Turns out this one is something we can actually do. Let me write there. 5 to the what equals 125? Well, the answer to that is 3. So this is just 3 plus log base 5 of x. And that's your answer. Okay. Notice we're not finding x-intercepts. Don't set it equal to 0. Don't try to solve anything. All you're doing is rewriting it. There's no solving in this section. All right. So I want to go show you on Desmos real quick what we just did. Desmos. And Desmos can do logs pretty well. Log base 5. Let me turn the projector mode on, turn off the grid of 125x. So there's my expression. But that's just the same thing as log base 5 of x plus, I'm going to put plus k. And then we can make this go from 0 to 3. So how much up does it go? Plus 3. So log base 5 of 125x is the same as log base 5 of x plus 3. So, I mean, I nerd out about this because for logs, it means that let's see, you have 125 on the inside, so that's going to be a compression. By a factor of 125. Whereas this is just up 3. So in terms of log, compressing my log 120 by a factor of 125, making it narrowing it down 125 times is the same as just picking the graph up 3. So I don't know. That's me nerding out. They're not going to ask you that on the homework, but I like it. All right. But anyway, let's go back to that. So let's look at this one. So this tends to get people. You have to ask yourself, what's the main idea? The main thing happening is you have two things being multiplied. You have thing 1 being multiplied to thing 2. So the main idea is still multiplication. So that means that we're going to do log of n plus log of a. The first one is u squared. The other one is v cubed. Okay, so notice how the first one goes in the first log, the second one goes in the second log. And now if I look at each one, I can keep going. So for this one, notice that the main idea is now the exponent. And it's actually the same for both. So what happens is we use the power rule. And the power rule gets the exponent and it brings it to the front. Gets the exponent, brings it to the front. And so we end up with 2 log of u plus 3 log of v. And that's it. That's your answer. Okay? So the reason why we do this, it's not just a parlor trick. It's used a lot in calculus. When you're doing calculus, you have to find derivatives and integrals. And it's easier to find the derivative of this, of the expanded part, than it is to find the derivative of the condensed part. If you wanted to find the derivative or integral of this one, log of u squared v cubed, that'd be really nasty. So instead what you do is you rewrite it, and then you take the derivative or integral of the easier function. Anyway, moving on to the next one. So I'm looking at this one. Again, we have to look at it and see what's the main thing happening. All right. So here, you have to notice, is this a times b to the x, or is it ab to the x? Okay, if you look at what's here, it's actually this one. It's a times b to the x. So the main idea is still multiplication. Okay, if it was exponential, it would have looked like this: 5e to the x. So if it was written like this, natural log of 5e to the x, then yes, the main idea would have been the exponent. Order of operations, say do the exponent first. But here, the main thing happening is I have a 5 being multiplied to an e to the x. So here, the main idea is multiplication again. And so we split this up. This becomes ln of n plus ln of n. And so the 5 goes here. The e to the x goes here. All right? And it's up to you how you want to simplify it. This ln of e to the x could be, get my calculator up and running. What we can do is similar to what we did last time. the main idea of the x can now go to the front of its own natural log. And so I get ln of 5 plus x ln of e. But if you go to your calculator, you can actually find ln of e. You do ln. E is, if you want e just by itself, that's second and pi. No, second divide, sorry. And there's e. Second divide gives you e by itself. And that's just 1. ln of e is 1, because remember the base of ln is e. And if the base and the inside are the same, the answer is 1. So my final answer becomes ln of 5 plus x. All right. Good stuff. Again, these are things that take practice. Let's go to one that's a little uglier. So here, what's the main idea? And these are easier to spot. You can clearly see here that the main idea would be division. Okay? If the main idea is division, then you split it up by the top and the bottom. The top always goes first. So this becomes log base 2 of n minus log base 2 of n. And you write down each expression. The a to the 4 goes here. The b to the 9 times c goes there. Okay? Now we work on each one. The main idea for the first one is now exponent. Here, the main idea is actually, again, multiplication. Because we have two things being multiplied to each other. So just because an exponent's there doesn't mean it's the main idea. It could be, but you got to watch out. All right, so I get the 4. I bring it to the front. We now have 4 log base 2 of a minus. Here, the main idea is multiplication. So this is going to split up into 2 logs. Log base 2 of n plus log base 2 of n. The b to the 9 goes here. That's what I boxed in green. And the c goes here. And that's what I boxed in purple. Okay. Now, if I wrote it like that, though, I'd be incorrect. And there's a reason for that. Usually here I wait for a pause and I ask the class and someone eventually spots it. But what happened here is I'm subtracting the entire it's minus the entire log. So the minus, or I guess I'll just put a box around it. This minus sign affects the entire log. So once you split it up, the minus sign still needs to affect the entire log. And we achieve that by putting parentheses. So what you're going to do is you're going to put parentheses here and a parentheses there. All right? So it's the minus still affects the whole thing. So even if you split it up, the minus still affects everything. Now we can distribute that minus sign. Notice how I'm keep on going. I don't know why I said that. So minus log base 2 of b to the 9 minus log base 2 of c. Now the last thing to do is this 9 comes to the front of its own log, and we're left with 4 log base 2 of A minus 9 log base 2 of B minus log base 2 of C. Okay. Now, as you get better at doing this, you start to skip steps because you're doing it in your head. But for the purposes of this exam, I need to have something to grade. If I can't grade it, I can't really give you points for it. Oop. So please, 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 when the exam does roll around, show your work, even if you can do it in your head. I keep on missing those 4s. Why do I keep on missing those 4s? There we go. All right. Okay, I was trying to figure out what happened. Okay. My bad. Okay, so again, you don't have to have this much work, but notice that we keep doing stuff with every step until we break it up as much as possible. And now there's nothing left to do. So my final answer would be this. Oop. Doop, doop, doop. All right, 2 more. Ooh, oh, 4 more. Okay, so again, this is just practice to make sure we know how to do things. This is the same idea. We look at this, and the main idea is division. And so for division, we have log base 6 of n minus log base 6 of n. So the cubed root of xy goes here. WZ squared goes here. All right. Now I'm gonna rewrite what I just wrote, but I'm gonna write the cube root as what it really is. So this is still W times Z squared. The main idea for this one is multiplication, whereas this one is really xy in parentheses raised to the 1/3. That's what the cubed root is. It's the 1/3 power. And so we ask ourselves, what's the main idea? Well, the main idea for this one is multiplication. The main idea for this one is exponents. And so we apply the rules. The exponent can come to the front. Here we have 2 things, and so we split it up with addition. So the exponent flies to the front. 1/3 log base 6 of xy. I'm going to split that up later. Minus, again, the minus affects the entire log. So even if I rewrite this, the minus is still going to affect the entire log. Log base 6 of w plus log base 6 of z squared. So there's going to be a parentheses around it because the minus still needs to affect everything. Now what else can we do? Same thing here. This is going to split up even further. I've got to start writing it a little small. Let me actually make things smaller. Okay. So here we have the 1/3 is affecting this whole thing. But notice the main idea is multiplication. So that's going to split up into log base 6 of x plus log base 6 of y. This one, the minus is going to distribute. Minus log base 6 of w minus log base 6 of z squared, because remember the minus distributes. Oh, too far. Okay, and then my last step is to move this exponent to the front of its own log and distribute the 1/3. Okay, remember you can't distribute inside. When I say distribute, it means you just slap it in front of the log, and that's all you're doing. These are fun. So your final answer is 1/3 log base 6 of x plus 1/3 log base 6 of y minus log base 6 of w minus 2 log base 6 of z. And there you go. Yay! Yay! Yeah. So anyway, that's that problem. This is kind of the ugliest that they get in terms of what you're going to be doing. This is probably as much work as you're ever going to do. Okay? And as you get better at it, when you get to calculus, you should be able to go from here straight to the final answer in your head. And your teacher's going to do that. Your teacher's going to, when your teacher's showing work on the board in calculus, they're going to say, oh, log base 6 of bleh, and then they're going to write this on the board as the next step. And you have to know basically all your log rules to know what they did. But for this section, even if you can do it in your head, remember, show me the work. All right, so these last couple things here are similar to what we just did, except they have x's in them, so they look scary, but they're exactly the same as the past 5 examples. So the first one is log of x times x plus 2 over x plus 3 squared. So notice the main thing here is we have, so what we don't want to do is don't distribute. Because notice the main idea is multiplication. If you distribute, if that's not the main idea anymore, and you can't do anything. So I have log of n minus log of n. So x times x plus 2 goes here. X plus 3 squared goes here. And then we work with each log individually. For this log, I can see the 2 is going to come to the front. For this log, I can see the main idea is multiplication. I have 2 things being multiplied. So this is going to split up into 2 logs. So log of x plus log of x plus 2 minus 2 log of x plus 3. Okay? And so this is where I tell you to stop. Okay? Because what's the main idea? The main idea is now addition. If the main idea is addition, you can't do anything. Remember in the very beginning? Okay? If the main idea is addition, you cannot split it up into 2 separate logs. You're done. Just walk away. All right. Anyway, let me put my phone on vibrate because I don't want someone to blow up the test. All right. So let's do the last 2. Oh, by the way, that was it. This was a really short problem. It looks complicated because of the x's, but really it was pretty easy. Okay, 2 more. And then we get to move on to page 3. All right. So again, we're going to work with the top and bottom. The main idea here is division. Before I even start, let me actually rewrite this. This is log of 2x, x plus x squared plus 3 to the 8, over on the bottom, this is 4 minus 3x. The square root is really the 1/2 power. Okay, so let me erase these two. So there we go. Be sure to write all your radicals, write them as exponents so that you can use the rules properly. So the main idea here is going to be division. And so it's log of meh minus log of meh. And so we have 2x, x squared plus 3 to the 8. We have 4 minus 3x to the 1/2. So we look for the main idea. The main idea for this one is multiplication, because you're multiplying two things, first of all. And here the main idea is the exponent. So this splits into two pieces, whereas the 1/2 is going to come to the front. So I have log of 2x plus log of x squared plus 3 to the 8 minus 1/2 log of 4 minus 3x. Okay, this one's done. This one is done because the main idea is subtraction. You can't do anything with that. Okay, now for this one, notice that there's still stuff I can do. I didn't write it, but this is really inside the log. The main idea is, again, exponents. So I can get the 8 and bring it to the front. Now, if you're looking at this and you're bored because I'm doing all 8 examples, then you're in a good position. Or, well, if you're bored because it's easy, then that's good. If you tune me out, then please email me. If you tuned out and have no idea what's going on, please email me so we can work on it and I can do my best to help you out. Anyway. So if you look at it, this one's done. This one was done. Now this one on the inside, the main idea is addition. That's the first thing you're doing when you're looking at the parentheses. And so it's done. You can't do anything. So your final answer is this long expression. All right, do one more, and then we're done with all the 8 examples. I like this one. I don't think it's in your textbook. I just like it because it makes me happy. So first thing I'm going to do is I'm going to write this as an exponent. The square root is really to the 1/2 power. Sorry. The 1/2 means that the 1/2 comes to the front of the entire thing. And here's what I was talking about earlier. Sometimes if the main idea is addition or subtraction, you can do certain things. Notice that the main idea is subtraction. And not just once, but twice. Okay? Now you can't split it up. Writing this will make Gilbert sad. Okay? So you can't split it up by 3 pieces. That's not what I mean where you can do something with it. That's poop. Okay? Instead, what we can do is notice that this is factorable. I have 1/2 natural log, and on the inside, I can turn this into x minus 7, x plus 2. With the main idea is now multiplication. So now I can split it up. So I have 1/2 ln of x minus 7, and then the 1/2 is going to distribute. And I have plus 1/2 ln of x plus 2. So that's just one I wanted to show you. I like it. It shows how you can churn a problem that you couldn't do anything with it, but because you can factor it, factoring turns the main idea from addition and subtraction to multiplication. And then you can split it up. And now the main idea inside each log is now addition or subtraction. I can't simplify it any further, and you walk away. Anyway, glad you made it all the way through. Oh, I didn't realize I had so many examples when I made this handout. But hopefully you've seen anything that I'll throw at you, and on the homework you'll be ready for basically. I'm just rambling. I'll stop. Okay. So page 3, there's only 5 of these, are condensing logs. And now what we're doing now is we're going backwards. Okay, so that means that we're going from log of m plus log of n, and we're making that and we're turning it into log of m times n. So now we're going backwards. From 2 logs, we go to 1 log. Same thing for subtraction. 2 logs become 1 log. Okay. Now, when you're going backwards this way, people always make this mistake, and they don't make the mistake for the multiplication, but they make the mistake for the log. They write this, and dear God, please don't do that. All right? Now, if you look at the next page, you'll notice that there is a theorem that has that, log over log, which even makes it even more confusing. So log over log is a thing, but it's not condensing a log. It's something else. So please don't write log over log. It's 1 log. Whenever you do the quotient rule, 2 logs become 1 log. All right. Anyway, let's get started. So the first one is 3 log base 5 of u plus 4 log base 5 of v. So we're looking at each log separately. Okay. I can't draw a box for the life of me. So we have 2 separate things here. And we're going to go backwards. Oh, the one rule I didn't write, which is the rule that we're actually using, is if you have r log of m, then basically the r becomes the exponent. All right, so that's what's happening. I don't know why I put the boxes. Okay. So the numbers in front of the logs become the exponents. And usually this is the first thing that you're going to do. Hold on, let me pause this real quick. Something's up. All right, sorry about that. All right, so the exponents are the numbers in front become exponents. So I have log base 5 of u cubed plus log base 5 of v to the 4. Now, the main idea is addition. So now I can bring these together as 1 log. Excuse me. And that's it. Look how adorable that is. So we went from multiple logs and we condensed it down to 1 log. Now, in order for this to work, not in order for this to work, but keep in mind that usually the Making the numbers exponents comes first. So turning the coefficients into exponents comes first. Okay, because in order for the addition rule to work, the product rule, the number in front of each log has to be 1. So that's why we got the exponents and the numbers in front and make them exponents first. All right, anyway, moving on to the next one. So here, what we can do is first we got to make the coefficients and turn them into exponents. Okay, now it becomes an exponent of the entire thing. So what we have is log base 4, x squared minus 1, minus log base 4. And so here we write this as x plus 1 to the 5th. Now, as you're working, it's implied that the raised to the 5th is inside the log, so you don't have to put the extra parentheses. But that's what's going on. Okay? Don't try to write it out. Don't factor it or expand it. It's just... So now the main idea in between is subtraction. So now I can condense them into one log. Now all that's left to do is sometimes when you're done, you just have to tidy it up and simplify. Okay, and there's no more log stuff. This is just basic algebra. On the top, you have x plus 1, x minus 1, because that's what x squared minus 1 is. X plus 1 to the 5th. And notice that one of them cancels out. And changes that to a 4. So your final answer is log base 4, x minus 1 over x plus 1 to the 4th. All right, that was the little twist in this problem. So in addition to doing the quotient rule, after you were done, you just had to do a little bit of more algebra to make it work. Right. In my opinion, I think condensing is a little nicer than expanding. Anyway, next one. The first thing we got to do is get the numbers and turn them into exponents. So I have log base 3 of x to the half minus log base 3 of y cubed. And now the main idea between them is subtraction. And so I have log base 3. Notice that it's one log. And x to the 1/2 over y cubed. If you want, you can write the x to the 1/2 as the square root of x. It's up to you. But anyway, that's it. Okay. Remember, it's not log over log. Gilbert will destroy you if you do this. Please don't do that. It's poop. All right. So next one. I have, remember, this is the same type of problem as this other one. The x's, if you look inside each log, the main idea is addition and subtraction, so there's nothing you can do. So really all we're doing here is making all these coefficients exponents. That's the first step. Okay, plus log of x minus 5 squared minus log of x plus 1 to the 4th. All right. Now notice that there's three things here. And so what you do is you kind of work at it one at a time. I'm going to work on these first. Because if I do that, notice that these become one log. Okay. And then I can work on the whole thing. Oh, I guess I don't need to highlight the whole thing. Just the subtraction. So now it's going to be one log. So log, and then on the top you have x plus 3 squared, x minus 5 squared, and on the bottom you have x plus 1 to the 4th. And that's it. Don't expand it. That's just a bunch of busy work. That's all I want. Okay? So if you have 3 logs, just do them. You can work from left to right, do them one at a time. So I did the first 2, turned it into one log, and then I factored it in with the last one. All right, now let's do the very last one here. Same idea. I'm going to get the 2 and bring it here. So I have log base 2 of x plus 1 squared minus log base 2 of x plus 3 minus log base 2 of x minus 1. And again, we can use the same approach. There's a shortcut to this one. Not a shortcut, but another way to do it. But I'm going to work it off like the same way we did last time. The main thing here is division. So 1 log and this is where people will get confused. Because now notice that this is another division. So we have 1 log, now again 1 log. And they have x plus 1 squared over x plus 3 divided by x minus 1. Okay? So, how do we do this? Usually people see this and they get scared. That's your face usually when you see that. Because it's not finished. Not finished. What you have to do is simplify it. And so, usually on the side, what I'll do, let me work with the simplifying on the side, and then I'll write the answer. So, what we do is this is now no longer has to deal with logs. But this is x plus 1 squared divided by x plus 3. And then the entire thing divided by x minus 1. So this is essentially what's going on. All I did was the big division symbol. I used the other division symbol. Now hopefully you remember from way back when that you can change division to multiplication by flipping it. And so from here we can see that this is just x plus 1 squared over x plus 3 times x minus 1. That's all it is. So you have to turn it into one fraction. You can't just leave it looking ugly like that. So let's do that. Move this down here. All right. So because of the side work, I know that this is the same thing as log base 2 of x plus 1 squared over x plus 3 x minus 1. And there we go. Yay! Okay, now this one, there's 2 ways to do it. So I want to show you the other way. And it avoids doing all of the work that I showed you earlier, which is kind of good. It's just a different approach, a different take. It's not pasting. Let me try it again. Duplicate. All right. So if I work this out a different way, and this is easier to sum if you notice it. Notice that I can take a minus out, and this leaves me with log base 2 of x plus 3 plus log base 2 of x minus 1. I'm trying to zoom in. Okay, so what I did here was these last two terms, they had a minus in common, so I factored the minus out. But now notice these two are separated by addition, so I can combine those together. So x plus 3, x minus 1. And now these are separated by subtraction, so I can bring them together. And honestly, this way is a lot quicker. It avoids all of the nasty stuff. But in the heat of the moment, people tend to forget this approach, and they'll just go from left to right, and you're left with the uglier version. But notice I got the same answer both ways. There's no wrong way to do it. It's just one way might involve more algebra than another way. Okay? So it's up to you how you want to do it. You can go from left to right. If you get a fraction over a fraction, then just do some algebra. Break it up, see what's on the top, see what's on the bottom. If you have another way to do it, that's fine. And you can, other way is you notice they have something in the common at the end and you factor it out. Anyway, last page, guys. Are you all still with me? Sure are, Gilbert. All right, so the very last thing here is what's called the change of base formula. And this is where you actually do see a log over a log. So the change of base formula means you change from one base to another. Notice here, this is my old base. Those are my new base. And there you go. So what it's saying is notice that let me try to write something out. I'll do an example. Let's say I have log base 5 of 27. Okay? I want to figure out what that is. Remember, this is saying 5 to the what is 27. Okay? So I want to figure out what that is. So what I can do is I can use the change base because I want to use my calculator to hook me up. But if you look at your calculator, it has two buttons. It has the log button and the natural log button. The log button is base 10, the natural log is base e. So let's say I choose base 10. So what you do, so doing it like that would be completely illegal. Let me put the 5 to the what above it. Okay. So that's completely illegal because you can see that this one and this one have different answers. 5 to the what equals 27 has a different answer from 10 to the what equals 27. So you can't just change the base and get away with it. What you need to do is divide by the log of the old base. So here we have log base 10 of 5. So there's two things. You just write your expression with the new base, But then again, that's very illegal. So you offset that, but divide by the log of the old base. Okay, so in this example, I have log, the base 10 is implied, of 27 divided by log of 5. Notice I get 2.0478. 2.0478. It's an approximation. And this is not what we're looking for. And so notice that if I go back to my original idea, 5 to the 2.0478, 5 raised to the 2.0478. Now, since I rounded, it's going to be a little off. Notice I got 26.999. That's really close to 27. So with logs, we're able to find really weird exponents. You're able to answer 5 to the what equals 27. 3 to the what equals 15. Things that you couldn't be able to do before, with logs, you're able to do it now. Anyway. Oh, one thing I wanted to mention also is notice I chose base 10. I didn't have to do base 10. I could have done, so let's do log of 27 divided by log of 5. I could have used ln instead. It doesn't matter. Oh, you can't mix match them. That's illegal. Notice that the ratios are exactly the same. So when you're converting logs, it's just whichever button you prefer, log or natural log. All right. Anyway, so on the homework, what you're going to do is you're going to write out and convert logs. So approximate the following logs. The first one says log base pi is 7. So I just do log of 7, ln of 7. It can be any base here. I don't know, 13. Why not? Of 7. So the inside just goes on the top. On the bottom, though, is the old base. Divided by log of the old base. Log of the old base. Log of the old base. Okay? So it doesn't matter what base you use. You can use, the reason why we stick to log and natural log is because these are the buttons in our calculator, and we're used to seeing them. But anyway, we can type it into our calculator. No matter which one you do, the answer is going to be the same. So let's say we do ln of 7 divided by ln, and the pi button is second caret. So 1.69989. What this means, again, is that we answered the question, pi to the what equals 7. Well, pi to the 1.69989 is very close to 7. Notice 7.0000. Right? So let's approximate log base 4 of 29. So it doesn't matter what you do. You can use log. You can use natural log. But what you do is the inside is just 29. But the penalty for doing that is you have to divide by log of the old base. The old base was 4. Natural log of the old base. So whatever base you used up top, you have to use that same base on the bottom. But the inside is whatever the old base was. And so let's work it out. ln of 29 divided by ln of 4. Oh, don't be like Gilbert. Actually, close the parentheses off or else bad things happen. 2.42899. So that means we're able to answer the question that 4 to the what? Is about equal to 29. Yay! All right, so anyway, there's not much to do with approximating logs, but you're able to find weird logs that you couldn't find before. Now here, I like these because these are usually bonus. You're not going to find them on the homework, but I like them because they're fun. So these are little puzzles that I'll probably give as bonus on the exam, and if you can do them, you can get an extra 5 points. But yeah, log base 5 of 1/2 plus log base 5 of 2/3. And so we can do this without a calculator. Okay. Notice that addition, they're all being added, which means that I can turn this into 1 log with all the insides being multiplied. So all we did was the product rule. Now, the cool thing is that the 2's cancel, the 3's cancel, the 4's cancel. So all I'm left with is log base 5 of 1/5. But that's just log base 5 of 5 to the negative 1. The log and the 5 cancel out, and you're left with negative 1. I like these. They're like little puzzles. All right, this last one involves the change in base formula. And it's similar to before. A lot of stuff's going to cancel. Notice that all the bases here are different. So you can't do things that we were doing before. So what we do is we change them all to the same base. I'm going to use natural log because it's one less letter to write. So I have ln of 3. The old base goes on the bottom with a natural log. Ln of 4. Ln of 3. So again, what I'm doing is this becomes this. This becomes this. And we keep on doing that pattern. Log base, now I'm using natural log. Natural log of 5. Oh my God. Over ln of 4. Ln of 6 over ln of 5. Ln of 7 over ln of 6. Ln of 8 over ln of 7. So I turn each one into a natural log. So again, this is the same as this. This is the same as this. This the same as this. This the same as this. And notice that when I do that, things cancel out. Ln of 3's cancel. Ln of 4's cancel. Ln of 5's cancel. Ln of 6's cancel. Ln of 7's cancel. And we're left with ln of 8 over ln of 2. But this is just the change of base formula. This is my old base. We're going backwards. So this is log base 2 of 8. And if you ask yourself the question, 2 to the what equals 8? Well, the answer is 3. Isn't that cool? Did all that without a calculator. These are actually things that you'll see on UIL math competitions. There's a mental math portion, and these are very popular questions that people do, and they'll compete. Anyway, let me know if you have any questions with this section. I believe in y'all. Y'all got this. Oh, where's my button? Y'all have a good day.